Let V be the real vector space of all polynomials in one variable with real coefficients and having degree at most 20. Define the subspaces W1 by this set and W2 by this set. Then the dimension of intersection of these two subspaces is. This type of problem asked in net type problem, numerical answer type. So we need to find dimension of intersection of two subspaces is again a subspace, so we can find dimension. Also, this is finite dimensional space W1 and W2, so intersection will be finite dimensional as V is a vector space of all polynomials in one variable with real coefficient. It means field is real with real coefficients and having degree at most 20. What it means, degree of a polynomial, suppose this is c naught plus a1 x1 plus a2 x2, the higher degree will be x raised to the power 20. If a polynomial of this type or a polynomial can be represented in this format, then this polynomial should come in vector space V, and the dimension of this vector space V is equal to a higher degree plus 1, so its dimension will be 21. So we need to find dimension of intersection by the property of intersection. If any element W1, if any element belongs to intersection, then it will follow the property of W1 and W2. And what are W1 and W2? W1 and W2 is defined or given by these two sets. So we need to find its dimension of intersection. So let's suppose, and what is the dimension? What is the meaning of dimension of any set or any vector space? Any vector space. It means if we choose an element any elements from vector space, then at how many points then at how many points points means at how many or how many constituents of this vector space these elements are free to choose. Suppose this is a vector space, sorry, element, and we are free here and free here and not here, then its dimension is 2, because we are free at 2 place and there are 3 constituents of this vector, so dimension is 2. Dimension of this vector space V will be 2. So here intersection, if any element belongs in intersection, then it will follow the property of intersection, and in intersection W1 and W2 then dimension of W1 intersection W2 will be 21, because an element belongs to W1 or W2 will have the dimension 21 if there is non-restriction or linearly independent restriction. So how many restrictions are there? P1, P1 is first restriction, will be an element belonging to intersection. P half, P5, P7, P3 and P4. P1, P half, P5, P7, P half, P3, P4 and P7. 1, 2, 3, 4, 5, 6. So subtract 6. So dimension is equal to 15. You can find dimension by this formula. Dimension of intersection. Dimension of intersection will equal to dimension of W1 plus dimension of W2 minus dimension of sum W1 plus W2. Using this formula, you will calculate dimension of the sum of W1 plus W2, and here there is no need to find dimension of W1 W2, and W1 and W2 dimension is easy to find, but some student can get confused in some of these W1 and W2. So this is best way to find dimension of intersection. So answer is 15.